Everyone, in today's lecture we have to see the laws of refraction of light at a plane surface. Already you are familiar with laws of refraction. It is also called as a Snell's law. And then what is the Snell's law? Sin I upon sin R is equal to the N2 upon N1 is equal to the V1 upon V2. This is the mathematical statement of the laws of refractions. And we have to derive on the basis of Huygens wave theory of light. Let us see the ray diagram related to it. Okay, yes, see this. What is AB? AB is nothing but a plane wavefront which is bounded by rays A dash and B C. This plane wavefront AB is obliquely incident at point A. As soon as it touches the point A becomes the secondary source and it emits the secondary waves in the second medium, that is nothing but a denser medium of refractive index N2. In first medium, refractive index is nothing but a N1. Okay, therefore at time t is equal to 0, this A reach the boundary which is nothing but a Mn. Then at time small t is equal to the capital T, B reaches the point C which covers the distance which is nothing but a V1 into T, where V1 is nothing but a velocity of light in the first medium and T is nothing but a time required to cover this distance. Therefore, this distance BC is nothing but a V1 into T. Okay, then the AE is nothing but a secondary waves which is represented by the AE. A is nothing but a secondary waves or secondary wavelets. Then this distance covers which is nothing but a V2 into T, where V2 is nothing but a velocity of light in second medium and T is nothing but a time required to cover this distance which is nothing but a AE. A is nothing but a secondary waves, where V2 is nothing but a velocity of the light in second medium. Okay, therefore distance BC is equal to the V1 into T, then AE which is nothing but a secondary wavelets which covers the distance which is nothing but a V2 into T. Okay, then this refracted wavefront is shown by the EC which is nothing but a tangent to the secondary waves. Again we can here plot the hemisphere. This hemisphere represents the refracted wavefront and this refracted wavefront is nothing but a tangent to the hemisphere and which is represented by the letter EC. EC represents the refracted wavefront, AB represents the incident wavefront. Okay, you know that when the light waves travel from one medium to the another medium, the velocity of the light goes on decreasing. Okay, and these light rays are refracted. Okay, then from this figure we can say that from the triangle BAC, what is I? I is nothing but a angle of incidence, and in triangle ACE, what is R? R is nothing but a angle of refraction. Then according to the trigonometry, what is the sin I? Is sin I is equal to, can I write? Sin I is equal to the BC upon AC. This is BC upon AC. Okay, then what is BC? BC is nothing but a V1 into T upon AC as it is. Okay, then what is the sign R from second triangle? Triangle ACE. In that triangle, what is the sign R? Sign R is equal to the AE upon AC. Okay. Therefore, what is the value of AE? AE is equal to the V2 into capital T upon AC as it is. Okay. Therefore, take the dividation of these two equations. We get sin I upon sin R is equal to the S V1T upon AC upon V2T upon AC, and this is equal to the V1 upon V2. Okay, therefore we get the equation, this sin I upon sin R is equal to the V1 upon V2 is equal to the N2 upon N1, which is equal to the constant, and this is called as a law of refraction. It is also called as a Snell's law. Snell's is the name of the scientist. This is also called as a Snell's law. Therefore, sin I upon sin R is equal to the V1 upon V2 is equal to the N2 upon N1, where N2 is nothing but a refractive index of the second medium and N1 is nothing but a refractive index of the first medium, and that ratio is always constant. This is the law of refraction. Therefore, law of refraction is defined as N1 sin I is equal to the N2 sin R, where R is nothing but a angle of refraction. Then second statement of the laws of refraction is incident waves, normal and refracted rays are in the same plane. These two statements are important. First one is nothing but a N1 sin I is equal to the N2 sin R, and second one is nothing but a incident rays, refracted rays and normal are in the same plane. Okay, this is the important point. Okay, now next point, which is again a simple one. Dependence of lambda means wavelength of light on refractive index n, Ri in bracket n. How wavelength depends on refractive index? We show the simple diagram. PQ is nothing but a refracting surface. These are nothing but a three wavefront, AB, CD and EF. This is A dash, B dash, C dash, D dash, E dash, F dash. Okay. Then this is nothing but a direction of propagation of light. Okay. See this. In this topic, we have to show that how wavelength depends upon the refractive index. Therefore, consider this ray diagram. In this ray diagram, what is PQ? PQ is nothing but a refracting surface. And what is A, B, C, D and EF? A, B, C, D, EF are the plane wavefront. Okay. Then, in this second figure, when this light rays travel from one medium to the another medium, then we get the second rays, which is nothing but a dash, B dash here C dash, D dash and E dash, F dash. ह्यांच्याबद्दल जे काही डिस्टन्स आहे आपण ते कमी दाखवलेला आहे पहा. कारण तुम्हाला माहिती आहे की ज्यावेळेस लाईट रेज हे एका मीडियम मधून दुसऱ्या मीडियम मध्ये प्रवास करतात त्यावेळेस त्यांची वेव्हलेंथ ही काय होत असते, कमी होत जाते. त्याच्यामुळे ही वेव्हलेंथ आपण इथं कमी दाखवलेली आहे. इन फर्स्ट मीडियम द वेव्हलेंथ ऑफ लाईट रेज इज नथिंग बट ए λ1 and in second medium the wavelength of the light rays is nothing but a λ2. Okay, therefore first consider that let the wavefront AB reach the boundary PQ at time t is equal to the 0. Then next wavefront, which is nothing but a CD, reach the boundary PQ at time t is equal to the capital T at a distance of λ1. This distance is nothing but a λ1. This distance is nothing but a λ1. Then what is the time required to cover this distance? Therefore, capital T is equal to the, what is the formula for capital T? Is velocity is equal to what? Distance upon time. Barabar? Distance upon time. Therefore, time is equal to the distance is nothing but a λ1 and velocity is nothing but a, in first medium velocity of the light rays is nothing but a v1. Okay, therefore we get in first medium capital T is equal to the λ1 upon v1. Okay, in second medium what do you get the T? T is equal to the s λ2 upon v2. Okay, therefore T is equal to this equation λ1 upon v1. T is equal to this equation λ2 is equal to the v2. Therefore we get λ1 upon v1 is equal to the λ2 upon v2, equating these two equations. Therefore we get this equation. Then write down this equation for λ2. Then what we get? λ2 is equal to the s. λ2 is equal to the v2 s into λ1 upon v1. Okay, therefore λ2 is equal to the, what is v2 upon v1 into λ1. Therefore we get λ2 is equal to the v2 upon v1 is nothing but a n1 upon n2 into λ1. Okay, therefore we get next equation λ2 upon λ1 is equal to the n1 upon n2. Therefore from this equation we can say that the wavelength of the light depends on refractive index of the medium. Again consider the frequencies of the two media. Frequencies of the light is always denoted by letter nu. This symbol is called as a nu. Okay. Then we consider nu1 is nothing but a refractive index of the first medium. Nu2 is nothing but a refractive index of the second medium. Then we can write down this v nu1 upon nu2 is equal to the, what is the formula for nu? In previous standard we have learned v is equal to the n lambda. Okay, in that equation v is nothing but a velocity, n is nothing but a frequency and lambda is nothing but a wavelength. Okay, from this equation what is the nu? Nu is nothing but a v1 upon λ1 upon nu2 ची व्हॅल्यू पुट करा v2 upon λ2. Okay, therefore from this equation what we get? Nu1 upon Nu2 is equal to this V1 upon lambda 1 into lambda 2 upon V2. Okay, then lambda 2 upon lambda 1. Okay, then V1 upon V2. V1 upon V2 ची व्हॅल्यू पुट अप केली आपण, तर what we get here is nu1 upon nu2 is equal to the 1, and therefore we get the last equation is nothing but a nu1 is equal to the nu2. Nu1 is equal to nu2 means when the light rays travel from one medium to the another medium, its frequency remains constant. Only the wavelength changes. As the wavelength changes, the velocity of the light rays also changes, but its frequency remains constant because frequency is the property of the medium. Okay, therefore we get here nu1 is equal to nu2. This is all about the dependence of lambda on the refractive index n. Okay, now let us explain the next concept, which is nothing but a polarization of light. This is the one of the property of light. What is that property of light? We have to study this. You know that according to the scientist Maxwell, light is an electromagnetic waves. It consists of electric vector as well as the magnetic vector. These two vectors are perpendicular to each other, and it is perpendicular to the direction of propagation of light. If this is nothing but a electric vector and this is nothing but a magnetic vector, these are nothing but a two fields and they are perpendicular to each other, and which is again perpendicular to the direction of propagation of the waves. Before that, we have to study the unpolarized light. Unpolarized light. What do you mean by the unpolarized light? Unpolarized light means a light in which the vibration of electric vector are in all possible direction is called as a unpolarized light. Which are the example of unpolarized light? Sunlight. त्याचे जे काही वेव्स असतात त्या सर्व डिरेक्शन्स असतात. ट्यूब लाइट्स असेल, then bulb, all these are nothing but a example of a unpolarized light. This unpolarized light is shown by the double arrow or number of arrows. This is nothing but a double arrow or number of arrows. This is nothing but a representation of unpolarized light. Then next definition, plain polarized light. Plain polarized light. Unpolarized light म्हणजे कळलं तुम्हाला की लाईट वेव्हचे जे काही व्हायब्रेशन्स असतात ते सर्व डिरेक्शन्सला असतात, त्याला म्हणायचं अनपोलराइज्ड लाईट. देन प्लेन पोलराइज्ड लाईट, ए लाईट इन विच द व्हायब्रेशन ऑफ इलेक्ट्रिक वेक्टर्स आर in one particular direction is called as a plain polarized light, and it is shown by the double arrow, and this is nothing but a direction of propagation of light. This is called as a plain polarized light. ओके, म्हणजे इथं काय घातलेले आहे, लाईट व्हायब्रेशन्स वर काहीतरी रिस्ट्रिक्शन घातलेले आहेत, त्याला म्हणायचं प्लेन पोलराइज्ड लाईट. मग अनपोलराइज्ड लाईट पासून आपल्याला प्लेन पोलराइज्ड लाईट मिळवायचं असेल तर आपल्याला आणखी कोणतं तरी एक मटेरियल तिथे वापरावं लागेल. दॅट मटेरियल इज कॉल्ड ॲज ए पोलरायझर. पोलरायझर हे असं मटेरियल असतं की इट कन्वर्ट अनपोलराइज्ड लाईट इनटू द प्लेन पोलराइज्ड लाईट. which allows only those vibrations which are parallel to the polarizing axis, and that material is called as a polarizer. This polarizer can be used as a polarizer. Polarizer and polarize हे एकाच अर्थाने इथं घेतलेले आहे. फक्त नेम मध्ये त्यांचे डिफरंट असले तरी त्यांचं काम एकच आहे. पोलरायझर अँड पोलराइड्स यांचं काम काय आहे? एकच आहे. They convert unpolarized light into the plain polarized light. Then what is the polarize? Then polarize consists of the two transparent brown color sheets. It is not transparent, but consider that these are nothing but a two transparent brown color sheets. Okay, if they are parallel to each other, then here is nothing but a behind this there is a unpolarized light. Then this unpolarized light incident on the first polarizer, then it convert into plain polarized light. Here we get the restriction of vibrations of the light. Okay, here we get the unpolarized light चं कन्वर्शन कशामध्ये झालेले? प्लेन पोलराइज्ड लाइट मध्ये झालेलं आहे. आणि इफ यू rotate this second sheets like this, then intensity of the light goes on decreasing. हळूहळू अनपोलराइज्ड लाईटची इंटेन्सिटी आपल्याला काय दिसणार आहे? कमी झालेली दिसणार आहे. हा एक्सपेरिमेंट सुद्धा आपण करू शकतो किंवा ऍक्टिव्हिटी आपण सिंपल करू शकतो. दोन पोलराइड्स घ्यायचे, नंतर इथं एखादा तुम्ही आर्टिफिशियल लाईट ठेवा. आर्टिफिशियल लाईट इज वर्क ऍज ए अनपोलराइज्ड लाईट. नंतर if the axis of these two sheets are parallel to each other, you will get the intensity of the light, decreasing light ची intensity मिळेल. परंतु जसजसं तुम्ही हा सेकंड पोलरायझर रोटेट करत जाल तसतसं इंटेन्सिटी ऑफ द लाईट काय होणार आहे? ही कमी होणार आहे. आणि इफ धीस two axes, polarizing axes, are perpendicular to each other, then intensity of the light becomes zero. Okay, म्हणजे if the axes are parallel to each other, then the intensity is maximum. If the axes are perpendicular to each other, then intensity is the minimum. Okay, then what do you mean by then polarization? Polarization is the basic phenomena in which there is a restriction of vibration of light waves in one particular plane is called as polarization.